That's all roads. Do something to us.
Yep. All right. So can you guys tell me which equation it was we skipped?
X minus 2. X minus 2. This is going to be on your website? +4.
+4 on the end? Okay.
It's going to be on your website?
It will be on the website. Okay. You guys ready?
Yeah.
Okay. So the parent graph for this one is y equals, what's the base of this one?
2.
Wait, which one has the exponent? The 4 has the exponent. So the parent graph for this one is y equals 4 to the x. So if we, are you guys ready? If we want to figure out the important pieces of information for this graph, the first thing we do is we plug 0 into the parent graph. What do you get if you plug 0 in for x?
1.
Yeah, 4 to the 0 is 1, so that's our first point. The second important point we get from plugging 1 in for x, so 4 to the 1 is 4. And then we always know that the asymptote starts off as a horizontal asymptote, vertical asymptote. Vertical asymptote? Horizontal asymptote. Sorry, that should be y equals 0. Okay. Got it? Right? Okay. So let's go ahead and write down what all of our transformations are. So can you guys tell me what you see on here? Stretch of 2. And is that stretch a vertical stretch or a horizontal stretch? Vertical stretch or horizontal stretch? Vertical. We've never done horizontal stretch before. We've only done vertical. So it's a vertical stretch. All right. What's the next one? Right 2. What's the last one? Up 4. Okay. So the first transformation that we are going to do on our chart is the transformation of vertical stretch of 2. Vertical stretch of 2. Should a vertical stretch of 2 change the x-coordinate or should it change the y-coordinate? Should change the y-coordinate, right? Because it's vertical and y is what goes up and down. So I'm going to put y in parentheses so I don't forget that. I'm changing the y-coordinate. And if you stretch something by 2, you make it twice as big as it normally is. That's what you do. So if we're taking our y-coordinates, what should we do with them?
Times 2. Times 2.
Times 2. We should multiply by 2. So I'm going to say, actually I'm going to say this is the y value times 2. All right, so the 0.01, the 0 for the x is going to stay, and when I take the 1 and multiply it by 2, I get 2. For the next point, the 1 is going to stay.
8.
I take the 4, multiply it by 2, I get 8.
0.
And then the last one, that horizontal line, is going to stay in the same place. Okay, so there's my first transformation. My next transformation is moving to the right 2. So if we're moving the graph to the right 2, is that going to affect the x value or the y value?
X value.
The x value. And how do we take an x value and move it to the right 2?
Add 2.
Add 2. So we're going to take our x value, we're going to add 2 to the x values. So our first x coordinate, instead of being 0, should be what? 2. 0 plus 2 is 2. The y coordinate is going to stay the same. Our next x coordinate was 1, so what should it be now? Should be 3. The y coordinate is going to stay the same. And a horizontal line, if you move it to the right 2, is still going to be in the same spot. So we got a horizontal line, move it to the right 2, same spot. So I'm going to say y equals 0. All right, and then our last transformation is what? Up 4. Is that going to change the x-coordinate or the y-coordinate? Up 4? Y-coordinate. And what are you going to do to your y-coordinate?
Add 4.
You're going to add 4 to move it up. So x-coordinate of 2 stays the same. What's the new y-coordinate? 6. X-coordinate of 3 stays the same. What's the new y-coordinate?
11.
12.
10.
And if you had a horizontal line at 0 and you shifted it up 4, what's your new horizontal line?
4.
4. Y equals 4. So one thing that we will notice about these asymptotes, these dotted lines that the curve gets really, really close to, is that the number on the end of an exponential function is actually the same as what the asymptote ends up being. So plus 4 means that we're going to have an asymptote of 4. Okay, so let's go ahead and sketch the graph. And you guys have a grid on yours, so yours should be easier. 1, 2, 3, 4. I got my horizontal line of 4. I don't think I made my graph big enough. I'm going to redraw mine. So go ahead and put your dotted line at 4 on your paper. And then we have a point at 2, 6. And we have a point at 3, 12. So when you graph this, you only look at the final column. This is what you decide to graph over here. The rest of this was us showing our work and explaining like how we did each of the transformations. But our final product, the final answer, is going to be what we get at the very end. So when we graph these, does everyone have their 2 points drawn? You always start at the point that's the... Huh?
Your graph isn't big enough.
I just want to go.
Ours is.
Oh, that's okay. So just go above it. It's okay if you need to do that for the one that's 12. 312? Yeah, so it goes 2 above your graph. Yeah. So you start at the point that's furthest away from the dotted line and you draw it towards the point that's closer. And then you follow that curve towards the dotted line because we know that curves get really, really close to the dotted line. And in this case, they just don't cross the dotted line. And then I'll continue this a little bit and draw an arrow because we know it's going to go up forever. All right. How do we feel about using the chart to draw these by hand?
Take a long time, but
It does take a long time. Do you feel like you can do it, though? Do you understand how the numbers work? So let's make ourselves a little cheat sheet. We've got stretches. We have compressions. And we have reflect over the x, right?
right.
And then we have left, and we have right, and we have up, and we have down. Those are all the different transformations we could have, right?
Right.
Okay. So if it's a stretch or a compression, those are things we either take the graph and we make it taller and skinnier, or we take the graph and we make it fatter and like wider, shorter. So these are things that happen to the y value. So you're going to multiply whatever that number is by y. Okay. The next transformation is if you reflect it. Are we listening? If you reflect it over the x-axis, that means you took a picture of a graph that was up here and you moved it down here. So if you take something that's up and you move it down, are you changing the x value or are you changing the y value? The y value, right? If you take something up and move it down. So that means that you're going to multiply the y by -1. That's how we deal with the reflection over the x-axis. We take the y coordinate and we multiply it by -1. How do we move a graph to the left? Yeah, we're going to say subtract from x. How do you move a graph to the right? Add to x. How do you move a graph up? Add to y. How do you move a graph down? Subtract from y. Okay. So as you're making your charts, eventually we want to be able to think through the chart and not have this list of things to kind of help us. But if you're struggling today, this would be like your little cheat sheet to figure things out, okay? I will not let you use this on a test. By the time we get to the test, you should understand how it works, that stretches and compressions multiply by the y, that left and right adds or subtracts from the x, that up and down adds or subtracts from the y. We want to eventually have those things understood, but for today, if you need that, that's totally fine. Let's go ahead and make sure that we can graph this to check our answer. So if you don't have your graphing calculator, go grab it. We're adding to our place. So the same thing for notes. last night. Oops, you need to go take them.
You didn't. That's very on deadbeat side. I want you to try. I came in the middle of the
Okay. So it should look like that. Now, we had a y value of 12, so go ahead and hit your window. We want our window to be big enough to show that y value of 12.
20.
So how could I change my window to make it so it shows that y value of 12?
Y max 20.
Yeah, make your y max bigger than 10, make it like 20. That would work. Does that look like the graph that we drew? Yeah, that looks like your graph. Good. Okay, so we want to find some characteristics of the graph. Now, what are some things that we know how to find for the graph? What do we usually find? Say it again. Domain and range. Okay, do you guys know what the domain is for this graph? So domain is from left to right, correct? Left to right. So we have an arrow that goes to the left. That's why Roderick was saying negative infinity. And we don't skip anything in the middle, so all these x values are used. And then what do we see on the right side? Infinity. We see an arrow, so we got another infinity. All right. How about from down to up? How far down does the graph go? 4. It doesn't go below 4, right? Do I put a bracket around 4 or a parenthesis? Parenthesis. Why is it a parenthesis, not a bracket?
Because it's not there.
Yeah, if you ask me, Ms. Rice, where does it hit 4? I'm going to say it doesn't. And then how far up does the graph go? Infinity. Perfect. Okay, what else can we do? Increasing and decreasing. So if I put my little stick figure on here, what is my stick figure doing? He's increasing, right? He's walking uphill. Does he ever switch to decreasing?
No.
No. So for decreasing, I'll say none. And what are the x values that we can see that he increases for? So our first x value right here is negative infinity. And our last x value over here is infinity. So we're making sure to get x values, not y values. What are some other things that we know how to get for characteristics of graphs? Max and min. Okay, so what do we see about max and min for this graph? There is none. No mountaintops, no valleys. Okay, what else? Intercepts. We got the x-intercept and the y-intercept. What do you guys see about the x-intercept? There's none. Why is there none?
It never touches.
Yeah, the asymptote keeps it from touching the x-axis, right? How about the y-intercept? So you plug it in already. So how do we find the y-intercept?
Plug it in 0 for x.
Yeah, so we've got a few different ways to look. We can do second trace, option number 1, and then, plug in 0. That would do it. What's another way you can find the y-intercept? Anyone know? We can look at the table. Yeah, if you go ahead and hit second graph, you can look at the table, and we can see that on our table we have 4.125. And this is a good time to check and just make sure that the 2, 6 shows up on our table. So when we got 2, 6, were we right? Is that a point that's actually on the graph?
Yeah.
Yep, that shows up on my table. Does 3, 12 show up on my table?
Yeah.
Yep. Is y equals 4 going to show up somewhere on the table?
Yeah.
Not necessarily. You can actually see it, though, if you try to get those negative x values. Or wait, where did it show up? Oh, yeah, it kind of shows up right here. Do you guys see how as we get those negative x values, our y-coordinate is getting closer and closer to 4? It kind of shows up right here. Your calculator just doesn't have that many decimal places. That's why it says 4 exactly. Okay, so how do we feel about these graphs? Are we okay with them? Okay. So, hey guys, what's the parent graph for number 1? Y equals 5. to the x. All right, so our important pieces of information, if we plug 0 in for x, what do we get? 5 to the 0 is 1. If we plug 1 in, what do we get? 5 to the 1 is 5. And then we always have the asymptote of y equals 0. So that's how we start our chart. And then what are the transformations that we have?
Stretch by 2.
Okay, so stretch 2. And then what's our next transformation? Right 4. And what's our last transformation? F3. Okay. So go ahead and see if you can do the first column. So the first thing we want to do is that stretch of 2. That's our first transformation we're going to do. Go ahead and see if you can do that column correctly. So what did you guys put for your first point?
0, 2.
0, 2. What did we put for our second point? 1, 10. What do we have for our asymptote?
Y equals 0.
Y equals 0. Didn't change. Okay. What's the next transformation we should do? Yeah, we've got to the right 4. Okay, go ahead and do that transformation to the right 4. So what was your first point after you moved it to the right 4? 4, 2. What's your next point when you move it to the right 4? 5, 10. How about the horizontal asymptote? Did it change? Nope. All right, and then last we're going to do up 3. Go ahead and do that one. What did you guys get for your points at the end?
4, 5. 4, 5. 5, 3. I mean 5, 13.
5, 13.
And 1 equals 3.
Y equals 3. And so now that we're at the end, this is what we're graphing. So we've got a horizontal line at 3. And then when we graph it, we always start at the one that's furthest away and draw it closer. I got that on the video. Oh.
Sick.
That's sick.
Mm-hmm. Sure, if I go back and replay it, that's exactly what it'll sound like. Did you just flick spit over here? Was it candy? You flicked something. I heard it hit the ground. I know, it's gross, right? Gross.
Disgusting.
Ew. Now, a lot of students get confused about number 2 because there are not very many numbers. So can somebody tell me what the transformation is? There's only one that's happening in number 2.
No. Down 8.
Down 8. Yeah, that's the only transformation, down 8. How do you guys know it's down 8 and not a right or a left? It's not in the exponent. The exponent is kind of like the inside of the function. The exponent is what has left or right. And this minus 8 is on the end, and that's what makes it down instead of left or right. Okay, let's go ahead and look at number 3 because we haven't done one like number 3 yet. So let's go ahead and write the parent graph. What's the parent graph for number 3? 3 to the x, right? Has a base of 3, so 3 to the x. So if we plug 0 in for the x, then what do we get? 1. If we plug 1 in for the x, what do we get? 3. 3 to the 1 is 3. And then we have a horizontal asymptote at 0. And what is the first transformation that you see in the equation?
Flip.
Yeah, flip or reflect over x. So that means that if the graph was above the x-axis, it's now below the x-axis, right? It goes from up to down. And then what does the plus 4 right here tell us? Left 4. Okay, so the first transformation we're going to do in our table is reflect over x. Do you guys remember how to do that? Yeah, you take the y-coordinate and you change it to a negative, or you multiply it by -1. So 0, +1 would become 0, -1. And 1, 3 would become 1, -3. And then the horizontal asymptote is in the same place. It just means that the curve, instead of being above the horizontal asymptote, is now going to be below the horizontal asymptote. That's what it means. All right, and then now we have to take the graph and move it to the left 4. So what happens to your x-coordinate? Subtract 4. So 0 subtract 4 is, so we got -4 and -1. 1 subtract 4 is, so we got -3, -3. If we take a horizontal line and move it to the left 4, does it actually change it? So horizontal line, left 4? No, so it's still the same. All right, so we have a horizontal line at 0. Let's go ahead and draw that. Horizontal line at 0. And then we have the point -4, -1. And -3, -3. And when we draw these, we always start at the point that's furthest away from the dotted line. And we draw it towards the dotted line, so towards the other point and then towards the dotted line. So that's what it should look like.